Hello students, today our question is a vibrating string of length L under a tension T resonate with a mode corresponding to first overtone, third harmonic of an air column of length 75 centimeter here and inside a tube closed at one end. So the string also generate 4 beats per second here when excited along the turning fork of frequency n. Now when the tension of string is slightly increased, the number of beat reduce here per second, assuming the velocity of the sound in air is 340. So the frequency n of the turning fork in hertz is, so A, B, C, D option is given here. So which option is correct? We have to find which option is correct here. So the solution of this question is, let f be the frequency of the, let f be the frequency of string. So according to closed open pipe, so we can write here in closed open pipe COP, we have the formula that is 3 time of velocity is divided by 4 time of length here. So we have velocity V is, velocity of sound is 340. So V is 340 here and L is 75. So if we put the values here, so we get 3 into 340 and this is 4 and this is 75. So we get the N is equals to, so we get the frequency F in the open closed pipe. So this is F here. So this will equals to 3 into 340 and this is divided by 4 into 75. So on solving this, we get this is equals to 340 kilo hertz here. This is not in kilohertz, this is only accordingly to hertz here. So we have the frequency of the turning fork. So it is the frequency of turning fork. So this must be addition of 4 bits or subtraction of 4 bits here, or 4 bit here. So either 336 and this is 346. So we have N is either this or this here, but in our case as tension is increased, so beat frequency decreases, but frequency of turning fork is also increased here. So this must be greater than 340. So we get the frequency of the turning fork N is equals to 346 hertz here, 344 here. This is if we add this with 4, so we get 344. So this is 344 hertz here. So our frequency of the turning fork is this. Now we check which option is correct here. So our option A is correct. Thank you.
क्वेश्चन दिया ए पुलिस कार मूविंग एट स्पीड ऑफ 22 मीटर पर सेकेंड एंड चेज ए मोटरसाइकिल. ठीक है. देन द पुलिस मैन साउंड्स हिज हॉर्न्स 176 hertz while both of them move towards a stationary siren of frequency 165 hertz. ठीक है. Then calculate the speed of the motorcycle if it's given that he does not observe any beats. ठीक है. तो पहले में ये 176 हॉर्न बजा रहा है. ठीक है, पुलिस कार. तो इसके लिए जो इसको फ्रीक्वेंसी सुनाएगा मान लेते हैं F1. तो F1 हो जाएगा, ये होता है रेशियो ऑफ रिलेटिव स्पीड बिटवीन साउंड ऑफ एयर एंड ऑब्जर्वर डिवाइड रिलेटिव स्पीड बिटवीन साउंड एंड ऑब्जर्वर सोर्स. ठीक है. तो पहले में ऊपर में आता है रिलेटिव स्पीड बिटवीन साउंड, मान लेते हैं स्पीड ऑफ साउंड 330 मीटर पर सेकंड है. ठीक है. ये साउंड इधर जाएगा और हमको इसका स्पीड चाहिए वेलोसिटी ऑफ ऑब्जर्वर, तो ये भी इधर जा रहा है, तो इसका रिलेटिव कितना हो जाएगा माइनस। ठीक है, अब ये यहाँ होता है रिलेटिव स्पीड बिटवीन साउंड एंड ऑब्जर्वर, ये इधर जा रहा है, और जो ऑब्जर्व सोर्स का वेलोसिटी है ये है 22 मीटर पर सेकेंड, तो ये हो जाएगा माइनस 22। ठीक है, इनटू ये कितना हॉर्न कर रहा है 176। ठीक है, सेम ये बोल रहा है कि ये स्टेशनरी सिग्नल है जो कि इसका वेलोसिटी 0 है, और ये हॉर्न बजा रहा है 165 से, तो ये इसका साउंड इधर जाएगा, ऑब्जर्वर खुद इधर आ रहा है। ठीक है, तो यहाँ से इसको मान लेते हैं F2 इक्वल टू 165 इंटू, यहाँ से लिखेंगे रिलेटिव स्पीड बिटवीन, ये हो जाएगा, ये इधर जा रहा है और ये इधर जा रहा है, तो यहाँ पे क्या हो जाएगा, रिलेटिव स्पीड यहाँ प्लस हो जाएगा, प्लस v डिवाइड बटे यहाँ पे हो जाएगा 330, ऑब्जर्वर सोर्स का कितना दिया है 0, तो ये हो जाएगा 0। ठीक है, अब बोल रहा है कि यहाँ पे कोई भी एनी बीट्स कोई भी ऑब्जर्व नहीं हो रहा है, इसका मतलब F1 माइनस F2 इक्वल टू 0 होगा, तो बस यहाँ पे पुट कर लेते हैं, तो ये हो जाएगा 330 माइनस v डिवाइड बटे 330 माइनस 22 इंटू 176 इक्वल टू 165 इंटू 330 प्लस v 330। ठीक है, तो यहाँ से जब हम सॉल्व करेंगे तो यहाँ से v का वैल्यू आएगा 22 मीटर पर सेकेंड। ठीक है, तो यहाँ से हमारा ऑप्शन हो जाएगा सेकेंड।
Hello students, today our question is two vehicle each moving with speed u on the same horizontal straight road approaching each other. Wind blow along the road with velocity w, and one of these vehicle blow a whistle of frequency f1, and observer of the other hears the frequency of whistle to be f2, and the speed of sound in still air is vc. So the correct statements is or are a b c d options are given here, so we have to find correct statement about this. So the solution of this question is, let this is our source here at this point, and it is traveling with u velocity and frequency f1, and here is our observer, and this is approaching the source with u velocity, and f2 is the frequency here. So we have two cases here. Case 1 is if wind blows from observer to source. So in first case we get f2 is equals to f1 frequency 1, and this is v velocity of the air, and w is air velocity of wind, and v is the sound velocity here, and this is plus u, and u is the uniform velocity of source and observer, and we have the v minus w, and this is u. So in this case f2 is greater than f1, as it is sometime it is multiplied with f1, so it gives some value, so this must be greater here. So from first case we get frequency 2 is greater than frequency 1 if wind blows from observer to source, and if wind blows from source to observer. So in this case we get f2 is equals to f1, and this is v plus w, and this is u, and here we have v minus v, and this is plus w, and this is minus u here. So in this we have frequency 2 is, in this case also frequency 2 is greater than frequency 1. So in both cases we get frequency 2 is, in both cases we get frequency 2 is greater than frequency 1. So now we check which options are correct here. So our option A, if the wind blows from source to observer, so frequency 2 is greater, and if wind blows from observer to source, then frequency of 2 is greater. So our option A and B correct here. Thank you.
Hello students, here is a question. A sound wave of frequency f travels horizontally to the right. It is reflected from a larger vertical plane surface moving to left with speed v. The speed of sound in medium is c. So first part A, number of waves striking the surface per second is, the wavelength of reflected wave is, the frequency of reflected wave is, the number of beats heard by the stationary listener to the left of the reflecting surface is. So this question has four parts. So one by one we solve, and it is given that a sound wave of frequency f, this is a frequency f, is traveling horizontally to the right, and then it is reflected from a vertical plane. Let assume this is a vertical plane and moving to left. After reflected, it moving towards the left, having velocity or having a speed v. Then the speed of sound in medium is c. First, in part A, we have to find number of waves striking the surface per second. In part A, number of waves striking the surface per second. So in this question, in this part, we have to find the F apparent, right? So F apparent is equals to original frequency into C minus of minus V, negative sign because of opposite direction, is divided by C. This is the relative velocity. So is equals to F into C plus V divided by C, right? So first option is correct. Number of waves striking the surface per second is F into C plus is divided by C. Now, after that, we have to find the frequency of reflected wave. So, we solve first part C, then part B. Frequency of reflected wave. So, we consider it as new apparent frequency, right? Which is equals to F apparent into C divided by C minus V. Now put the value of F apparent. So F apparent is F into C plus V is divided by C into C divided by C minus V. This C cancel with this C, and we have F into C plus V is divided by C minus V, right? So this is the frequency of reflected wave. So I think this option is incorrect because the frequency of reflected wave is F into C plus V divided by C minus V, right? Now come to the B part, the wavelength of reflected wave. Come to the part B, the wavelength of reflected waves, that is lambda. Lambda is equals to C divided by F apparent, new F apparent. So which is equals to C into C minus V is divided by F into C plus V, right? So this is the value of lambda. So this option is correct. Now, fourth option, number of beats heard by a stationary listener to the left of the reflecting surface is. So, beat frequency in part D, we find the beat frequency means FB, which is equals to new apparent frequency minus frequency of wave. Now put the value, that is F into C plus V is divided by C minus V minus of F, so which is equals to F into C plus V minus C plus V is divided by C minus V, now which is equals to 2FV is divided by C minus V. Now check the options. Here the third D option is incorrect because the correct answer is 2FV divided by C minus V. I hope you understand. Thank you.
Hello students, today our question is two men are walking along a horizontal straight line in the same direction. The man in front walks at speed 1 meter per second, the man behind walks at speed 2 meter per second, and a third man is standing at height 12 meter above the same horizontal line such that all three men are in vertical plane and the two walking men are blowing identical whistles which emit a sound frequency 1430 here, and the speed of sound in air is 330. At the instant when the moving man is 10 meter apart, so the stationary man is equidistant from them. So the frequency of the beat in hertz heard by the stationary man at this instant is. So the solution of this question is, we have, firstly we can draw the diagram for it to understand it better. So this is observer, that is stationary, and we have A, and this is B here, and we have the angle theta here, and this is theta, and this is 12 meter here, and this is 5 meter, and this is 5 meter, and the velocity of this is 1 meter. So this is in this direction is 1 meter per second, and in this direction we have 2 meter per second speed of A, and we have, from this we can apply the cos theta is equals to 5 by 13 here, base divided by perpendicular, base divided by hypotenuse by Pythagoras, this is 13 here, so this is base divided by hypotenuse, so this is our cos theta here. So now we can find the apparent frequency, that is apparent frequency AF is equals to, that is frequency of the sound, so this is 430 here given to us, then the frequency of sound in air, so this is 330, and speed of air is 330 minus 2 time of cos theta, as the velocity is 2 here. So from this we have written this as apparent frequencies f0 and speed of sound, and this is v minus va. So we have this is equals to apparent frequencies 430, and this is 1 divided by 1 minus 2 cos theta, we have taken 330 common here and cancelled out here. So we get apparent frequency is equals to 430 and this is 1 plus 2 cos theta, and this is 330, and we have written this as using binomial expansion. So we can write here by using binomial expansion here. So from this we can write here apparent frequency of B. So this is apparent frequency of B, that is A, and this is apparent frequency of A. So we can write here, denote it, so no confusion will create here. So this is the B, and this is B here, B into apparent frequency of B. So this is 430 and this is 330, and we have this is 330 plus 1 cos theta. So from this we get B, and this is FA here. So B and apparent frequency of B is equals to 430, and we have taken the common here, and similarly by using expansion we can write this 330 here. So from this we get delta change in frequencies, FA is equals to FB, that is equals to 1430, and this is 1 minus cos 30 cos theta, and this is 330 here, and this will equals to 13 cos theta here, and we have the cos theta is 5 by 3. So from this we get delta F is equals to, and F of A and F of B, apparent frequency of A and B is 13 into 5 divided by 13. So this is equals to 5 Hz here. So this is our answer for this question. So the frequency of the heard by the man at any instance. So this is 5 Hz here. So this is our answer. Thank you.
Well, hello students, now we're going to see this question. The question says that a source of sound with frequency 256 Hz is moving with velocity v towards a wall, okay, and an observer is stationary between the source and the wall, okay. When the observer between the source and the wall will hear beats, okay. When will the observer hear beats? Will the observer hear beats? We need to say that. So firstly, I'll make you explain with a diagram that let's suppose this is the wall, okay. And basically, let's suppose this is the observer standing over here, okay, and basically a sound source of frequency is coming. So basically, let's suppose this is the sound source of sound, okay. I'm drawing the source of sound. Let's suppose this is the source of sound, okay. This is a speaker, let's suppose, and it is producing the sound, okay. So this is the sound source, and it is moving, okay, this in this direction with a velocity v, okay. So if you understand over here, the sound waves will go right from here, okay, like this. They will go, okay, from the speaker itself, and firstly they will reach the man, okay. The apparent frequency will reach the man, not the normal frequency. Why? Because this source is moving, and basically this basically the sound waves will also cross the man and reach the wall, okay, this wall behind the man. So basically the sound waves reaches the wall basically, and basically they reflect back, okay, they reflect. So what is this scenario? We can also assume, okay, that another source, okay, of the same frequency basically is moving towards the man with the same velocity v. Since this frequency, the reflected frequency and this frequency of the thing is same, there will be no beats observed, okay. So since the source frequency, source apparent frequency and the reflected frequency is same, hence the observer won't hear beats. The observer won't hear, will not hear Beats. Why? Because beats formula is beats equals to frequency 1 minus frequency 2, and over here both frequencies are same, so there will be 0 beats. Okay, thank you.
Hello friends, today we are going to see this problem. An observer standing on a railway crossing receives frequencies 2.2 kHz and 1.8 kHz when the train approaches and recedes or leaves from the observer. Okay, find the velocity of the train. Speed of the air is given. Speed of the sound in air is given. Now, what is the question? There is a stationary observer standing at a railway crossing. When the train is approaching towards it, it hears the frequency 2.2 kHz. Okay, and when the train leaves, it hears the frequency 1.8 kilohertz. Okay, so we need to find the velocity of the train. Okay, so this is the question. Now suppose when the train is approaching the observer, the frequency hit by the observer is f1, that will be equal to velocity of the sound upon v minus vs. As it is approaching towards the observer, that why we are writing minus here. Okay, into f. Okay, and when it leaves, the frequency becomes f2 is equal to v minus v plus vs. As it is leaving, the we will use plus here into f. This f is the original frequency. Okay, so let's take the ratio of f1 and f2. f1 upon f2, that will become v plus vs upon v minus vs. Okay, now the f1 is given 2.2 kilohertz and f2 is 1.8 kilohertz, that is 11 upon 9. Okay, now cross multiply, we will get 9v plus 9vs is equal to 11v minus 11vs. Now let us calculate vs in terms of v. As we know, the v is the velocity of the sound, and we need to calculate the vs. So 20 vs is equal to 2v and vs is equal to v upon 10. Okay, so the value of v we know, vs is equal to the value of v is given as 300 upon 10, that means 30 meter per second. This is the velocity of the train. Okay, thank you for watching.
Hello everyone. So today we're going to solve this question. The question says, a boat is traveling in a river with a speed 10 meter per second along the stream flowing with a speed 2 meter per second. From this boat, a sound transmitted is lowered into the river through a rigid support. The wavelength of the sound emitted from the transmitter inside the water is 14.45 mm. Assume that the attenuation of the sound in water and air is negligible. What will be the frequency detected by a receiver kept inside the river downstream? So here we have to find the frequency that is detected by the receiver. Second, we have to find the transmitter and the receiver are now pulled up into the air. The air is blowing with a speed 5 meter per second in the direction opposite the river stream. Determine the frequency of the sound detected by the receiver. Here they have changed the medium and they have pulled up into the air, and then they have told us that the air is blowing the speed 5 meter per second in the opposite direction of the river stream, and for that we have to find the frequency of sound detected by the receiver. Here they have given us the temperature of air and water, the density of river water, bulk modulus, gas constant, and the mean molecular mass, and Cp by Cv for air. So we are going to use all these in a formula here to solve this question. Okay. So here, now we will use what? We will use the Doppler's effect. But here what is happening is that the medium in which the sound traveling is also in motion. The medium in which sound is traveling is also in motion. Okay, so from here we will say that the frequency will be what? The change frequency is equals to the original frequency, that is mu naught, into c, the velocity of the sound, plus the velocity of the medium minus the velocity of the observer, divided by the velocity of the sound plus the velocity of the medium minus the velocity of the source. Okay, so we are going to use this formula. Now, you must know that when the source is moving toward the observer, then the velocity of the medium is what? Positive. Okay, and when the source is moving away from the observer, then the velocity of medium is negative. Okay, also when the source and observer are approaching towards each other, then when the source and the observer are approaching towards each other, then we say that the velocity of source is what? Positive. Okay, and the velocity of observer is what? Negative. And when they are, this is the approach condition, and when they are far away, then what happens? Then the velocity of source is negative and the velocity of observer is positive. Okay, so now let us see in the first part, they have told us to calculate the frequency retrieved by the receiver that is kept inside the river downstream. Now here let us consider that this is the boat. Okay, they have given us that this is moving in the direction that is with a 20 meter per second speed. Okay, and this is the stream that is 2 meter per second. Okay, so this is our transmitter and this is our receiver. Okay, so that means that this is our source and this is our observer, and this is the, let's say this is the river. Okay, so now first let us find the velocity of sound. So the velocity of sound here is what? C is equals to under root by bulk modulus divided by rho. So that is equals to what? Under root 2.088 into 10 to the power 9 divided by 10 to the power 3. So that will give us what? That will give us 1445 meter per second. So this is our value for C. That is the velocity of sound. Now here if you see from the diagram, the velocity of medium is what? 2 meter per second. Okay. And the velocity of observer is what? Because the source is moving towards the observer, so velocity of medium is 2 meter per second positive. The velocity of observer is 0 because it is not moving. And the velocity of sound is what? Because it is approaching, so it will be plus 10 meter per second. Now let's apply the formula and find the change frequency will be equals to what? Mu dash will be equals to mu naught 1445, that is C, plus 2, that is the Vm, and V0 is 0, plus 1445 plus the velocity of the medium 2 minus the velocity of the source, that is 10. So from here we will get mu dash equals to mu naught 1.007. Now you know what mu naught is equals to what? C by lambda. So C we have calculated 11445 and lambda they have given us 14.45 mm, so into 10 to the power minus 3. So this will give us mu naught is equals to what? 10 to the power 5 hertz. Place it here, so it will be mu dash equals to 10 to the power 5 into 1.007. Okay, so from here we will get our mu dash equals to what? 1.007 into 10 to the power 5 hertz. So this is our answer for the first part. Now in the second part, they have told us that the transmitter and the receiver are now pulled up to the air. Now they have told us that the air is blowing with the speed 5 meters per second opposite to the river stream. And for this, we have to find the change frequency. So, for this case, let us again calculate the velocity of sound. Because here the medium is changed. So, velocity of sound will be equals to what? In air, given by C equals to under root gamma RT by M, that is molecular mass. So, now placing the values, we will get 1.4 into 8.31 into 20 divided by 28.8 into 10 to the power minus 3. So from here we will get 344 meter per second. Okay, so this is our C. Now here, since the medium is air, so this is the transmitter and this is the receiver. This is the observer source and this is the observer. And this is moving in this direction. Stream is in this direction, okay? And here they have given us the the velocity of sound in air is moving in this direction, okay? And here it is given us that it is moving with a 5 meter per second speed. Okay, so from here we will say that the Vm is what? Minus 5 meter per second, because it is, as you can see, it is moving away from the observer. And Vs is plus 10 meter per second, and the observer is 0 only. So from here we will get the nu double dash is equals to nu naught. Here again we apply the same form, that is C plus Vm minus V naught divided by C plus Vm minus Vs. Putting the values here, you will get nu double dash equals to nu dash 344 minus 5 divided by 344 minus 5 minus 10. From here, we will get nu double dash equals to nu naught is what? 10 to the power 5 into 1.03, or nu double dash equals to 1.03 into 10 to the power 5 hertz. So this is our frequency for the second part. This is our answer. So I hope you understood it. Thank you.
Hello students, here is a question. A band playing music at a frequency f is moving towards a wall at the speed vb. A motorist is following the band with the speed vm. If v is the speed of the sound, obtain an expression for the beat frequency heard by the motorist. So in this question we have to find the beat frequency. Now motorist will observe the beats due to two apparent changes, right? Due to two apparent frequencies, and one which is directly listened by the motorist, and the other which is due to reflection reflection from the wall, right? First we calculate these two apparent frequencies by the motorist. The frequency directly heard by the motorist, that is f1, which is equals to f plus v plus vm divided by v plus vb into f, right? And the frequency after reflection, that is f2, this is frequency after reflection, is equals to v plus vm divided by v minus VB into F. Right? Now we have to calculate the beat frequency. Beat frequency is F2 minus F1, right? So which is equals to V plus Vm divided by V minus Vb into F minus V plus Vm divided by V plus Vb into F, which is equals to, now we calculate and we get 2VB bracket V plus Vm divided by V square minus VB square into F. So this is a beat frequency. I hope you understand the explanation. Thank you.
A source of sound is moving along a circular orbit of radius 3 meter with an angular velocity of 10 radian per second. A sound detector located far away from the source is executing linear SHM along the line BD with an amplitude BC equal to CD equal to 6 meter. The frequency of oscillation of the detector is 5 by pi per second. The source is at point B. When the detector is at point B, if the source emits a continuous sound wave of frequency 340 Hz, find the maximum and the minimum frequencies recorded by the detector. In the question, frequency is given, so we can find angular frequency omega is equal to 2 pi f. 2 into pi into f is 5 by pi. Pi got cancelled out. So angular frequency is equal to 10 radian per second, and this angular frequency of detector matches with that of source. When detector is moving from B to C, C to D, source is moving anti-clockwise. A1, A2, A3. So source is going far from the distance, far from the detector. So in this case, frequency is minimum using Doppler effect of sound. Taking case 1, by Doppler effect of sound, apparent frequency f dash is equal to f into V minus V naught divided by V minus Vs. And in this case, when source and observer are going far from each other, in this case observer velocity is in positive and source velocity is in negative. First we need to find V0 and Vs. So V0 is equal to amplitude into omega. So V0 is equal to 6 into 10. So V0 is equal to 60 meter per second. And now Vs is equal to R into omega. So Vs, R is 3 and omega is 10. So Vs is equal to 30 meter per second. And taking velocity of sound in air 340 meter per second. Now we can find f dash. F dash is equal to, frequency is given 340 into 340 minus 60 plus minus Now 340 minus minus plus 30. So f dash is equal to 257.3 Hertz. This is the minimum frequency. Now second case, when detector moves from D to C and C to B, in this case source is moving from A2 to A3 and A3 to A, right next to A. Case second, in this case source and detector approaching. So in this case, in case of approaching, frequency is maximum, and in this is a case of approaching. So in this case Vs is in positive and V0 is in negative. Now we can find f dash in this case is equal to, f is 340, V is 340, minus minus plus, V0 is 60 divided by 340, plus minus minus, and Vs is 30 meter per second. After solving this, we get f dash, which is equal to 438.7 Hertz. This is the maximum frequency. These are the answers.
Hello. Question is, two tuning forks with natural frequencies of 340 Hz each move relative to the stationary observer. One fork moves away from the observer while the other moves towards him at the same speed. The observer hears beat of frequency 3 Hz. Find the speed of tuning fork. એટલે આપણે લોકોને શું બોલ્યું છે? પહેલા તો આપણે લોકોને ખબર છે કે જે ફ્રીક્વન્સી સ્પીડ છે સાઉન્ડની એ શું છે? 340 મીટર પર સેકન્ડ, રાઈટ? અને જે ફ્રીક્વન્સી આપેલી છે f એ શું છે આપણું? 3 હર્ટ્ઝ બીટ ફ્રીક્વન્સી, રાઈટ? અને જે નોર્મલ ફ્રીક્વન્સી છે, પહેલા તો કેમ કે જે ટ્યુનિંગ ફોક છે એ વેલોસિટી ઓફ સોર્સ આપણે લોકોને ફાઇન્ડ કરવાની છે, રાઈટ? તો આપણે લોકો શું લખી શકીએ? જે ફ્રીક્વન્સી છે આપણી એ છે n, કેમ કે બંનેની ફ્રીક્વન્સી સેમ જ છે 340 હર્ટ્ઝ, રાઈટ? તો પહેલો ટ્યુનિંગ ફોક દૂર જાય છે અને બીજો પાસે આવે છે, એટલે આપણે લોકો લખી શકીએ n1 equals v by v minus vs into n, અને બીજો જે છે n2 equals v by v plus vs into n, રાઈટ? એ થશે. તો આપણે લોકો લખી શકીએ કે જે આપણી બીટ ફ્રીક્વન્સી છે એ શું હશે? v by v minus vs minus v by v plus vs into n. એટલે આપણું જે અહીંયા આન્સર આવશે એ શું આવશે? v into n કોમનમાં, અને આવશે v plus vs minus v plus vs, એટલે 2vs by v square minus vs square આ આવશે, રાઈટ? તો આપણી લોકોની વેલ્યુ જે છે, કેમ કે આ આપણે લોકો શું કરી શકીએ આમાં? કેમ કે આપણી જે ફ્રીક્વન્સી છે બહુ નાની છે, એટલે એ જે vs છે એ બહુ જ નાનો છે v થી, એટલે આપણે લોકો અહીંયાથી શું લખી શકીએ? fb જે છે એ આવશે 2nvs by v approximately, રાઈટ? તો અહીંયાથી આપણે લોકો vs ને શું લખી શકીએ? v into fb by 2n, એટલે આ થઈ જશે v. v કેટલું છે? 340 into fb. fb કેટલું છે? આપણું બીટ ફ્રીક્વન્સી 3 હર્ટ્ઝ ડિવાઈડ બાય 2 into આ 340 છે, આને આ કપાઈ જશે, આ આવશે 1.5 મીટર પર સેકન્ડ. તો આપણો આન્સર શું છે અહીંયા? 1.5 મીટર પર સેકન્ડ. Thank you.
Moving rapidly towards a wall with velocity 5 meter per second. How many beats per second will be heard if sound travel at speed of 330 meter, right? So let us say that this is a wall, right? So this is a source of sound, say S, and this is our observer. The speed is given, velocity of source is 5 meter per second, right? And the value for C is equal to 330 meter per second, right? So now let us say f dash, that is frequency, equal to v plus velocity of observer. So observer is stationary here, right? Our observer is stationary, so it will be a 0 upon v minus velocity of source. Source is moving at this direction, that is same direction, so the sign will be negative, so minus vs, right? Multiply by frequency, which will give us the value of f dash, which is equal to v upon v plus vs into f, right? So for f double dash, we have again v upon v minus vs, velocity of sound, multiply by frequency. Here sign will not be, sign will remain as it is. So the fb, that is beat, frequency of beat, will be equal to f double dash minus f, which is equal to f and v will be the common, right? In the bracket we will be have 1 upon v minus vs minus 1 upon v plus vs, which will give us fv v plus vs minus v plus vs upon v square minus vs square, the basic mathematical calculation, right? Further, after solving all the above equations, we will remain with fv upon 2vs upon v square minus vs square. So after putting the value, we will be having 256 multiplied by 330. So in bracket 2 into 5 upon 330 whole square minus 5 square, right? So after solving all this equation, we will be having the value of beat, that is 7.7 hertz. This is the correct answer for the given question.